Wait, don't do it yet.
I'm not. I'm not. I'm just getting it started for the at homers.
There's no internet at home.
Oh, we just don't know.
I thought you meant with people.
Yeah.
No, I'm just getting it started so that they see the warm-ups before, and then, because what they should do then is they should pause the video here and then do them and then see the answers. All right? What's up? All right, so if I have to find domain, vertical asymptote, and horizontal asymptote for these two functions, what's the first thing I have to do?
Set the denominator. Sorry.
No, go ahead.
Set the denominator equal to 0.
Is that what you were going to say?
Yeah.
Okay. All right.
I'm sorry, Dad. Next time I'll raise my hand.
No, that's okay, Roz.
Or raise it. Whatever I speak.
So I get x equals 0, right?
You sure do.
Okay. So then what is my domain?
All real numbers, but x doesn't.
Okay. So then what's my vertical asymptote?
0. X equals 0.
X equals 0, not just 0.
Sorry.
Yep.
I fixed it.
Yep.
I fixed it.
Nope, that's good. Okay. Yes? Okay. Horizontal asymptote. That's step number 2 on our cheat sheet. It says we got to compare degrees, right? What's the degree of the top? 3. What's the degree of the bottom? 1. So big over small means none.
So it should be 3.
What do you mean?
Because it's 3 over 1.
Right.
Yeah.
But that's comparing the degrees.
Yeah.
And the comparison of the degrees
I
says
can correct what we
that
said.
it's big over small means no horizontal asymptote. Yep.
Aren't they less
Okay? Second one now. Gotta set the denominator equal to 0. Gotta solve it. Gotta square root it. Gotta get plus or minus I square roots of 6.
Oh, whoa. I thought you factored that out.
Can't,
Why? It's
because it's a negative.
it's a positive.
What do you mean it's positive?
It's plus 6.
Yeah, so then you gotta subtract 6 to move to the other side.
Yeah. Okay. So we did one yesterday where you could factor it.
Right.
So what was the difference between that one and
It was
the one?
minus.
So it would have been minus 6?
No, it would have been, yeah, so it would have been x squared
And then-
minus 6.
okay.
Yeah. Mhm.
See, I don't understand this now.
Okay. So, now here's my important question.
Okay.
What's the domain?
It's
Why? Because those are imaginary, right? So there are no restrictions. So the domain is just all real numbers. Now, we could have also used a little logic too. If I put in a negative number into this denominator, I square it. A negative number squared is positive, okay? Positive plus 6, even more positive, right?
Yeah.
Not 0. Okay? Let's put 0 into the denominator. 0 squared is 0 plus 6, 6, not 0. Put a positive number in there. Positive number squared, positive, plus 6, more positive, not 0. So this denominator can never be 0, so there's no restrictions in that.
You find it based on plugging in.
Or by solving it, either one. Keep going. Hold on, I get 2 questions left. Go ahead, Rob.
no, I forgot.
Okay, go ahead.
If you have plus or minus I, you'll always have just all real numbers.
Because they're imaginary, they're not real.
So if you have I, it's always going to be all real numbers.
Unless there's something else, yeah.
We got it.
Okay? So what's my vertical asymptote?
All of them? No.
There isn't one.
Yeah, that's what I was thinking about.
Horizontal asymptote now. What's the degree on the top?
2.
2. What's the degree on the bottom?
2.
2. So they're the same, right? So then what do I look at?
2 over 1.
The lead coefficients, right? Which is 2 over 1. So we can just say that 2. So we're going to say it as y equals 2. Yep. What was it? This was the title slide.
No, I need like a title.
Day 4.
Day 4.
Rational functions, day 4. Well, that's what it would. That's all it would have said. Sorry, I'm not that creative.
Maybe do it in
Yeah. Okay. So with that being said, now I want you to find me all of the asymptotes for all 3 of these functions.
Okay, I can do that.
I know you can.
Wow.
So did you start with by putting the denominator equal to 0?
Yes.
Okay. So that should be 3x squared plus 1 equals 0. 3x squared equals -1.
That's right.
X squared equals -1/3. That's not real.
What?
Yeah.
How does x squared
So they're
equal
all-
-1/3? That's not real. Oh.
Right? So it's not real.
Yeah.
Right?
Yeah.
So there's no vertical asymptotes in any of these 3. Right? So there's none in all 3.
So
Okay.
it's not real.
In 1 second.
Why?
Oops. That breaks. Right? Okay. First one, does it have a horizontal asymptote? What? Y equals 0. Yep, because 0 is a number. Okay? Because we got a degree of 1 on the top, degree of 2 on the bottom, gives me a horizontal asymptote of y equals 0. Okay? Second one, does it have a horizontal asymptote? Two-thirds. Yep. They'd all be all real numbers because they all have the same denominator. Y equals 2/3? Yep, because it's the same over the same. Third one, none. So that one doesn't have any asymptotes whatsoever. Okay. Now, the point of these 3 is that with just one minor tweak, because the only thing that's different is this is just 2x on top, and now it's 2x squared, and now it's 2x cubed. With that one minor tweak, it totally changes the graph. Okay? The graph gets totally changed around with just one little minor tweak. So these steps that we're going through, that we're developing, they're super important that you follow them every single time, because then that's what gets you to where you need to be. Okay? All right. Let's add to our extra sheet. Okay? So if you want to write them, if you want to write these in your notes, that's fine. If you just want to write them right on your extra sheet, these steps, the 3 steps that we're going to add today, are the easiest of the 3 steps. Okay? Okay? It's just saying that, it's just a reminder that this is going to go on your extra sheet. Like the last couple of times we put something on a sheet, we first did it in our notes, and then we went to our sheet. This one we're going right to it.
I like it though.
Okay. Now I gotta stop it though at when it's small. If I stop it when it's big, then it stays big. Stop it when it's small, it stays small. So step number 3 on your sheet. Remember, step number 0 you got space for yet. Step number 1 was find the domain in any vertical asymptotes. Step number 2 was find the horizontal asymptote. Step number 3 now is we need to find the y-intercept. The y-intercept is going to be where our function crosses the y-axis, but really it is where f, I shouldn't say it, tap the brakes, not where f of is equal to 0. No, it's where we plug in 0 for x, because it's where x is equal to 0. So we're going to plug 0 into our function and get out a value. Now, that the form of our y-intercept will always be 0, comma, some number. Always. Okay? And it's got to be in point form. Just like the asymptotes have to be in line form, this has got to be in point form. So if it has a y-intercept of 2, we're going to write that as 0, comma 2. And we write it in point. Okay. All right. How many y-intercepts can we have? If we have more than one, let's say we had 2, is it a function? No.
The vertical line test.
Because the vertical line test would fail. So how many can we have? 1 or none. Because if we have if our vertical asymptote is x equals 0, then we wouldn't have it. Okay?
So if we don't have one, it's not.
So if we don't have one, it just has none for y-intercept. Yep. So that's a 1 or none case. Okay. Good on that. Fourth step on our cheat sheet. Now we're going to find the x-intercept. This is where our function, that's a bad R. I don't even know what that was. Where the function crosses the x-axis. For this one, we're going to set the numerator equal to 0. And we're going to solve. So that's the top. We set the top of the fraction equal to 0, and we solve. This is going to have the form some number, comma 0. How many can we have? As many as whatever the degree is of the numerator, that's how many you're going to have. Okay? Can we have 0? Good on step number 4. Did step 3. Did step 3. Okay? Now, here's where it's going to, we're going to get one more step to do. we're going to skip to step 7. So I need you to skip some space for step 5 and step 6. Okay? So we're going to skip to step 7 because step 7 is our last step. Okay? So step 7 says that we're going to find other points on our graph using a T-chart. Okay? Because we want to have, or you want, I should say, because that's going to tell you where your graph's going to go, at least 2 points in each zone. Now you're going to say, Lynn, what's a zone? Yeah. So, no, not quadrants. Okay? So when we have vertical asymptotes, that breaks our graph up into zones. So if we have one vertical asymptote, I've got 2 zones, left zone and right. If I've got 2 vertical asymptotes, I've got 3 zones, a left one, a middle one, and a right. Okay? So you want points, you want to know where the function's going in those areas, so you want to have points in those areas. Okay? Ready? Keep your cheat sheets out. Go to your graph paper now, because here we go. Okay? 1, 2, 3, go. Okay? So we want to do this without a calculator. Right when you walk in. Okay? We want to use our steps. Okay? And then at the end, we want to state our asymptote and end behaviors. Okay? So here we go. Step number, well, first off, write it down. Yep, definitely write down what the function is. F of x equals 2x over x plus 1. Okay? Step number 1 says we do what? Set the denominator equal to 0. Solve. Roz, you said what? X plus 1 equals 0?
Yep.
So that means x equals negative 1. So what is my domain? Love it. All real numbers except x cannot equal negative 1. Which means my vertical asymptote is x equals negative 1. How is that going to go on my graph? Dash line at x equals negative 1, right? Okay. All asymptotes are always dashed, yes. All the way across. Nice thing is you don't even need a straight edge for this one because vertical and horizontal, they should be on the grid line. But if you want to use one, I'm not going to stop you. Okay? Step number 1 has now been completed. Step number 2. Find the horizontal asymptote. Degree of the top. 1. Degree of the bottom. 1. That's the same, right? So now we look at y equals 2. Yep, we look at the coefficients. So it's y equals 2. That line is going to go on our graph. 2 up from the origin. Lead coefficient on top is 2. Lead coefficient on the bottom is 1. Step number 2. Done. Step number 3. How do we find the y-intercept? We're going to plug in 0 in for x. Okay? So I'm going to find f of 0. If I plug in 0, then that's going to be 2 times 0 all over 0 plus 1. 2 times 0?
0.
0 plus 1? So I have 0 over 1, which is 0. So my y-intercept is going to be what point? 0, comma 0. Not just 0, Alex. So we got to write it in point. Okay? So that's this point right there. Step number 3. Done. Step number 4. Find the x-intercept. How do I find the x-intercept? So that would be 2x equals 0. So x is 0. The origin is one of those where it's a both point. It's the only point that is both an x-intercept and a y-intercept.
How do you get that?
What does it say?
Got it.
That the numerator equals 0. Top. Yep.
We got a y-intercept that happens to do x plus 1, or is that because it's already the...
Because the y-intercept is where x is 0. So if there's an x on the top, you got to put in 0 there too. Okay? Good with that. Okay? So step 1, 2, 3, and 4 are all done now. We don't have step 5. We don't have step 6 yet. So step 7 says we got to find some more points. Figure out where this thing is actually going. Okay? So I'm going to go over here. I already have 1 point in this right zone. So I'm going to try 1. I'm always going to try 1 right close to my asymptote. And then I'm going to try 1 way far away. Over 10. Okay. If I plug in 1, 2 times 1 is 2. 1 plus 1 is 2. 2 divided by 2 is 1. So this goes to the point 1, comma 1.
You're plugging in.
I plugged in 1 into my function for x. 2 times 1 is 2. 1 plus 1 is 2. 2 divided by 2 is 1. So it goes through the point 1, comma 1. Okay?
It's
So then it would be 20 over 11.
20 over 11, which is a little bit less than 2, right?
1 and something.
1.9-ish? 1.82?
So can you say the 2 over 2 equals 2?
2 over 2 equals 1. Right? So what did you say, 1.8-ish? 1.82? So that's probably going to be like right in about there. So there's the right half of my function. Is there decimal equivalent? 20 divided by 11. That, or know that 20 divided by 10 is 2. So 20 divided by 11 has got to be a little bit less. Okay, now we got to do the other side. Well, I would do -2, because it's right next to my asymptote.
Oh, okay.
I would do -3, because it's the next one. And then I would do -10. 2 times, oh, what?
Why did you choose 3 this time and 2 the first time?
Because I already had 1 on the other side.
Oh,
Yep. -2 times 2? -4? -2 plus 1. -1. -4 divided by -1?
4.
4. No, -2, 4. Can't put it at -1, because -1 is my vertical asymptote. Nothing touches that. 2 times -3? -3 plus 1? -6 divided by -2. 3. So it goes through -3, comma 3. Two times -10? -20. -10 plus 1. It's going to be a little bit more, right? 2.2. What was that?
So then do you just go like this and up?
They go a little bit more than 2.
I just don't understand why you choose the numbers.
Why I choose? I always go for sure the next one on either side of the vertical asymptote. Okay? For sure that one. Then I usually go 1 more after that, and then I go to the far side of my graph. Okay? Agreed? Now, here's the cool part. The last couple of days, we've been doing logic to figure out end behavior and asymptote behavior. Now that we have a graph, we can get it right off the graph. So end behavior here, as x goes to infinity, my function is going to 2 from below. Because as x goes to infinity is the right side of my graph, the right side of my graph is approaching 2 from below.
Do you always write as x approaches infinity, and then it's also just the right side is
The right side is going to positive infinity, yes. And then as it gets closer and closer to positive infinity, it's getting closer and closer to 2 from below. Because that's what my horizontal asymptote is.
-10, and then that's the one for the section 1. So why is it positive?
Because a negative divided by a negative is positive.
Yeah. Well, you have to write the -20.
Divided by -9.
Yeah, like the -10.
Positive 2.2.
Okay,
When I put it in knowing, I get -20 over -9. No, it's what I got when I put it into the function. Okay. Over here, as x goes to negative infinity, f of x is approaching 2 from above. So that's my end behaviors. Then I got asymptote behaviors. As x is approaching -1 from the right, my function is going to negative infinity.
Can you explain that?
Right side of my asymptote, it's going down. As x approaches -1 from the left, my function is shooting up, so it's going to positive infinity. So what I would like you to do now is I would like you to graph this one. Then I want you to tell me the asymptote and end behaviors. Okay. All right. So x squared minus 4 equals 0 gives me x squared equals 4. Square root both sides gives me x equals plus or minus 2. So my domain is all real numbers, but x cannot be plus or minus 2, which gives me vertical asymptotes at x equals 2, and, or if you wanted to put a comma there, that would be fine too, x equals -2.
Is this gonna be informative tomorrow? All the graphing?
Degree on the top is 2. Degree on the bottom is 2. That's the same. So my horizontal asymptote then is going to be y equals lead coefficient over lead coefficient. -2 over 1 is just -2. Plug in 0. -2 times 0 squared is 0. 0 squared minus 4 is -4. That reduces down to 0. So my y-intercept is 0, 0. Well, I had 0 minus 4, which is -4. Yeah. Set the numerator equal to 0, 2x squared equals 0. So x squared equals 0, so x is equal to 0. So then that would give me my x-intercept of 0, 0 also. If it's 1, it's both for the order. Okay? Now we got to find some extra points. So let's start over here. Let's go with 3 and 10. If I plug in 3, 3 squared is 9, times -2 is -18. 3 squared is 9, minus 4 is 5. -18 divided by 5 is -3.6.
There we go. That's why. So we're doing.
Yeah.
Wait.
I'm listening.
Can you go over that one more time? So you do -2 times
9.
squared?
Yes.
Which is
So
9.
3 squared is 9, times -2 is -18. Now, order of operations. Just doesn't matter. You just pick them. 10 squared is 100, times -2 is -200. 10 squared is 100, minus 4 is 96. That's going to be a little bit more than -2.
Where's the first one going?
Right there.
What line is that?
positive 3, comma, negative 18/5. So there's that side of the graph. Then we've got insides. Negative 1 and positive 1. 1 squared is 1 times 2 is negative 2. 1 squared is 1 minus 4 is negative 3. Both of those end up being 2/3. Don't you want to know where your graph goes, though?
Oh, I guess. How are we gonna graph it? Why do we have to graph it? Because it's algebra 3.
Because it's college algebra.
So that's
There you go.
what we discussed.
Okay?
I'm trying to figure out.
Hold on. Yep. So now I've got end behavior and I've got asymptote behavior. All right? So for my end behavior, I've got as x goes to positive infinity. My function is going to negative 2 from below.
I'm not.
Right side.
Yep, got that. But where's the negative 2?
That's what my horizontal asymptote is.
Oh. Oh, and it's under, okay.
Because it's under.
Yeah,
Yep.
got it.
Okay? Actually, both sides it's under.
Yeah.
So both sides it's going to approach negative 2 from below. Okay?
But then it's negative.
Now I got asymptote behavior. So I've got as x is going to negative 2 from the left. I've got as x is going to negative 2 from the right. I've got as x is going to positive 2 from the left. And I've got as x is going to positive 2 from the right. Okay? So left side of my left asymptote going down, function going to negative infinity. Right side of the left asymptote going up, left side right asymptote going up, right side right asymptote going down. Which part? Do you understand the graph?
Yeah.
Okay. So then the end behavior is the left and the right sides of the graph. Okay. Asymptote behavior is
That's all?
this is just end behavior over here.
Yeah, I know. And then the one with the 4 is asking.
That's asymptote behavior. Yep.
Yeah.
Okay. And so you got to go both sides of any vertical asymptote. So if you only have one vertical asymptote, you only got to do 2 asymptote behaviors.
So we had
If you've got 2, you got to do 2 on each one, so that means 4. I forgot to put this on the video. So you can finish off your worksheet now, okay? And there's a formative assessment tomorrow in class, and that worksheet is due
tomorrow.
tomorrow.
Awesome.
Okay. It's only 4 problems, and you should have 3 of them done already.
Correct.
Oh, nice to you.